Now in this tutorial, we'll be looking at JAMB related questions on measurement and unit in physics. Alright, so the first one says that a boy walks 10 meter due west and then 10 meter due south. His displacement is. Now let us draw the diagram. So due west, this. Now south, this. So this is 10 meter and 10 meter. So from here, now the displacement, okay, so take note that this is 90 degree. And for the fact that here and here is the same, and here is 90, automatically here is 45, and here is 45. Now to this end, let us find the displacement, and you can see from the option we are giving both the direction. Alright, so to this end here, we can say finding the hypotenuse here, so you can just h square, let's represent it as h, then 10 square plus 10 square using Pythagoras theorem. So here you have 100 plus 100, which will give us 200. Finding the square root of 200. Now you can see here we have solved, so it implies that you will not use calculator. So this will now give us the square root of 2 times the square root of 100, which will give us 10 times the square root of 2, which will give us what? 10 root 2 meter. Now, since now the direction southwest is 45, so here we have 10 root 2 meter, and okay, so this is the right answer. Alright, let us move to number 2. Now for number 2, we are told that which of the following are derived units. Here we are given meter, we are given coulombs, we are given kilogram, ampere, and joules. Now we have that A, 1 and 2, B. Now these are just the options, and we know that for derived units, now they are gotten from fundamental units. Okay, and first let us list out the fundamental units here. Meter is a fundamental unit. Now kilogram is a fundamental unit, and amperes is a fundamental unit. Now to this end, from this option here, anyone that has 1, so out. Anyone that has 3, out. Okay, anyone that has 4. So within this, okay, this 1, 2, 3, automatically this should be the right answer. So coulombs, and coulombs now is ampere seconds, okay, and joules, that will be probably energy, that will be or work, force times what? Distance. Okay. Alright, so number 2, B is the right answer. Let's move to number 3. Now for number 3, we are told that the student measures the internal and external diameter of a cylinder vessel as 100 plus or minus 1 millimeter and 104 plus or minus 1 millimeter respectively. Now the possible error in the determination of the thickness of the vessel is. Now here what we need to do is, since here we have the value, that will be 100, okay, and here the thickness, that will be 104 minus 100, okay, this will give us 4. Now but for the error, plus or minus 1 plus or minus 1. Now for the error here, we need to just to add the two of them. So here you have plus or minus 2 millimeter. So the thickness here is 4 plus or minus 2 millimeter. So the possible error is plus or minus 2 millimeter. A is the answer. Alright, thank you. Let us move to number 4. Now for number 4, we are told that which of the following are scalar quantities. Now we have torque, electrical potential, kinetic energy, and momentum. Alright, and we know that the scalar quantity is that quantity that only has magnitude, that is numerical value without direction. Now we know that torque is a vector. Let us just V. We know the electrical potential is scalar, kinetic energy is scalar, and momentum here is a vector. So we only have 2 and 3. Let us look at the option 2 and 3. All right, D is the answer. Now let us move to number 5. Now for number 5, we are given this diagram. Now in the diagram shown above, Km represents the magnitude and direction of a force which is resultant of forces represented in the magnitude and direction by. Alright, now we know this is a parallelogram, and since we are told that Km represents, so Km, which means the arrow start from K and proceeds to N, okay, and we are told now, okay, which represents the magnitude and direction of which of the forces here. Now here we have NK, NK, and KL, which means the arrow is like this and moves like this, okay, and NK and KL here, and this arrow is moving opposite like this, okay. All right, now for this KN, which means the arrow goes up, and KL, the arrow moves this, okay, and okay, sorry, KL, okay, and KN, arrow moves up, and KL, the arrow moves from here back to K. And to this end, now we know that for parallelogram, now the vector movement is like this, okay, because this direction represents, or the arrow represents, the magnitude and direction of, these are the two forces it represents. So the one at the middle here serves as the resultant of KN and KL. Now you must always consider the arrow, okay. Thank you, and let us move to number 6. So the best option here is C. All right, thank you. Now for number 6, we are told that the unit of momentum is, now these are the options. Now you ask yourself, what actually is momentum? Momentum is the product of mass times acceleration. So product of mass times acceleration, and we know that mass is given as kg, which is the unit, now times, now that of velocity is meter per second, right? So in essence, this is kg ms as in meter per second, okay. Now to this extent, now let us split all this. Now joules here is actually force times distance. Now we have times seconds, right? So here we have this, we end up having this, and our Newton in essence is kilogram meter per second square. So here we have and forces in Newton, that will be kilogram meter per second square, now times distance is in meter, then times second per second, okay. So at the end of the day, we end up having kilometer meter square, then per second cube, okay. So that one is wrong. So for the Newton here, we have kilogram meter per second square times second. So this will give us kilogram meter. Now taking that this is 1, so minus 2 plus 1 will give us what? Minus 1. All right, I guess we've gotten the answer. So there's no need of solving this since we've gotten the answer. So is B. All right, now let us move to number 7. Alright, for the seventh one, a boy pulls a box along a horizontal table with a rope inclined to the horizontal at angle 60 degrees. Now if the tension in the rope is 40 Newton, what is the effective horizontal force? And we are given all this trigonometric ratio to make use of, which implies that you shouldn't use calculator. So let us say this is the box. Now and it's inclined to the horizontal, that will be 60 degrees, and this is the tension in the rope, 40 Newton. Now the horizontal force, which is this, that is F. Okay, now you can see that this forms a right angle triangle, and if you look at it, now you have 60 degrees, and you can see right angle triangle as I said. So it means that this is the hypotenuse A, and this is this is adjacent A, and this is the hypotenuse H. So the relationship between 60, 40 and the horizontal force will then be cos 60 using SOHCAHTOA, then equals the adjacent, which is F, then all over hypotenuse, which is the 40. So now making F the sort of relation, we have that F equals to 40 now cos 60 degrees, and we are told that 60 degrees is 1 over 2, so it implies that 40 times 1 over 2, 2 here 1, 2 here 20. So the horizontal force is 20 Newton, and which is option A. Alright, now let us move to number 8. Now for number 8, we are given this vernier caliper scale, and we are told that the reading of the vernier caliper shown above is, and this is these are the options. Now looking up here, we have the main scale and the vernier scale, and you can see it started from 3, and here we have what, 4. Now first of all, let us ascertain the intervals here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10. So which implies for every line here is 0.1, 0.1 throughout. So here is 3.1 down to 3.9, and this is 3.5, right? So here, but this vernier scale here starts before 3. So let us ascertain the value before 3 here. So here you have 3, so automatically here will now be 2.9 and 2.8, right? So for the main scale, because you have to add the main scale and the vernier scale. So here for the main scale you have 2.8 centimeter. Now plus, now let us now ascertain that of vernier caliper, and where you will need to focus on now is which of this tribe now are at the vernier scale align with the main scale. And if you look at it closely, you agree with me that it is this particular one. Okay, and for the vernier scale it is 0.01. now down you can see this 1, 2, 3, 4, 5, then 6, 7, 8. So here we have 0.08. Okay, so it's hard time we now add both. Here you have 0.08 centimeter, which will give us a 2.88 centimeter. All right, so and that is option C. Now let's move to number 9. Now let's look at number 9, and it says that a body is acted upon by two forces, 6 Newton and 8 Newton, as shown in the diagram above. The resultant of the force is, now you can see this is 6 Newton to the east and 8 Newton to the north. Now let's form a triangle from this diagram. Now here you have 6 Newton moving in this direction. Now take note, initially this is it. So for the direction to be accurate, so here you have this and going, this is 8 Newton. Then our resultant from here up there and forms an angle to the north, theta, so which is alternate to the angle inside the triangle. Take note, this is a right angle triangle. Now to that effect, and here is our resultant, R. So let us find the resultant. Now, using Pythagoras theorem, R square will give us 8 square plus 6 square, which will give us 64 plus 36, because 8 square is 64 and 6 square is 36, and the sum of 64 and 36 will give us 100. Then R, we have the square root of 100, which is what? 10 Newton. Alright, for us to now get the direction, you can see this is the angle. Now the relationship between the angle 6 and 8 here, you will see that this is opposite in relationship to theta, and this is the adjacent in relationship to theta. So using the SOHCAHTOA, we have that tan theta will give us opposite over adjacent, which is 6 all over 8. Reducing the fraction, we have 3 all over 4. To decimal, we have this should be 0.75. So to this end, theta will now give us the inverse tan of 0.75, and 0.75 by calculator, 0.75 will give us 36.85. That is 6.85. Now from the option we're not seeing 36.85, so approximate, so that will be 37 degree. Alright, so to this end now, here we have that this is the north, 10 degree Newton, 10 Newton and 36 degree. Now to which of the direction? This is north and east. Okay, so this is the angle here, northeast. So A is the right answer. Alright, let's move to number 10. Now for number 10, we are told that the dimension of power is, now we are given the option. Now let's look at power, and we know that power is the rate of doing work, that will be work over time. Now let us reduce work to the various quantity. That will be force times distance all over time. Okay, and force also can be reduced to mass times acceleration times distance all over time. And for mass, the dimension of mass is the capital M. Now acceleration, okay, let me do like this. Now for mass, the unit is kilogram. Okay, now for acceleration, it is meter per second square, and for distance it is meter, and time it is what? Seconds. Now the dimension for kilogram is the capital M. Now the dimension for meter is L, length. Now the dimension here, you can now see you have meter per second square, so here you have, this is L. Then for seconds it is T, so here you have T raised to the power of -2. Okay, now let us now plug in all this. So here we have that the mass, which is M, now times acceleration is L T raised to the power of -2, then times the distance, which is also in meter, you have L, then all over T. Okay, now let us collect like term here. So here you have, this is M, so L times L will give us L raised to the power of 2, and take note that this is T, which is the same thing as saying ML T raised to the power of 2 times L times T raised to the power of -1. Okay, because T raised to the power of -1 is the same thing as 1 over T, so which implies here that T, now -2 plus -1 will give us what? -3. So this is the dimension, and which of these fit in? Alright, number A. Okay, and that is the final. Alright, if you love what I've just done, can you subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and mathematics. Thank you and God bless you.